So, at this point, what we are going to do is to check the state of an IPM but on the electronic board. For that we have the following images and also a previously recorded video that we will analyze together. Take a look at how this measurement is being done. The first thing we have to detect is which of the poles of the IPM is the positive and which is the negative. Remember that the idea is to control all this with the equipment connected, but without having to disassemble it completely, with the equipment installed without power. You will only see this side of the board. So, we have the capacitors, we have negative and positive pole, and what we are going to do is to search for continuity between the positive pole and the different points of the IPM to find which is the positive. We are going to put the multimeter in continuity position. Keep in mind that this is very well varnished, so you will have to find points where you can make measurements, such as these small perforations. These perforations are to pass with the continuity or with the track from one side to the other of the board. They are perforations that allow us to make measurements. So, we put the multimeter there and in the different points of the IPM to see in which one it gives continuity. We will continue with the video. We see that there is no continuity and there is continuity. Well, there we have identified one of the two poles. We were able to identify the positive or the positive input to the IPM. We continue, we move on to the negative side. We are measuring from the negative of the capacitors and we are going to control on all the different points to see with which one we have continuity. And there we can already see it. It has continuity with the first. So this is the negative input. Very well, what are we going to do now? We are going to put the multimeter in diode position because what we have to do is to control these diodes. Remember that here we were with these diodes connected in parallel to the IGBT, and what we are going to do now is to try from the positive towards U, V, and W. What are we going to be controlling? Well, these must be completely open. There should be no continuity. Usually, when they burn out, they go into short circuit. So we try in diode position. From W to P, we are going to measure this diode, and that will give us a parameter that internally the IPM is in good condition. We will go from W to P, also from V to measure it is diode, and also from U to measure this third diode. We will not control the IGBT at this time, because it has a high resistance, it must be open, and when it burns out, it usually gets stuck. So what we are going to do is to control this diode in parallel to be able to check its state. And the same we will do from negative. We will go towards U with a negative also towards V, and also towards W, checking in diode position the multimeter, always checking the value of this diode that we have here. Well, then let's see how in the video we do just that. The resistance, or rather, the voltage drop of the diodes, will be the same as all the diodes, only it will be a little higher because they are diodes with more electron flow that support more current, so the voltage drop is even lower. Let's continue with that. We advance a little in the video, and notice that we are not measuring from the IPM, we are measuring from the capacitors, towards W. We know that this goes through the IPM, we already know that. So we have then between positive and W, placing the electrons from the positive, we have the voltage drop of a diode. Energizing or sending the electrons from the positive to the W, now from the positive to the V, we also have the voltage drop of a diode and also towards the U. We sent electrons from the positive to U, V, and W, and the voltage drop of a diode appeared. Returning to the diagram, what we did was send electrons from the positive to U, V, and W, and we clearly see that the diodes are placed in direct. The electrons must pass. So far, we are good. We continue advancing, and what we are going to do now is to invert, and we are going to send the electrons from the other side, from the U, V, W. Notice that here we have the negative, and although at first a small data appears, then what happens is that it opens. So it remains open as it should. The electrons do not pass through those three diodes. Well, to this point, from the positive, or rather, from U, V, W to positive, the diodes are in reverse. Then we mark OL. Now what we are going to do is to go from the negative, because we also want to test the other three diodes. What we want to do now is to test from the negative to U, V, W to test these three diodes, and with them the three IGBTs. Now we are going to go to the negative, and sending the electrons from U, V, W should give me a voltage drop. We send electrons from U, V, W to the negative, and the diodes are indirect. We take it well. And now what we are going to do is to invert the cables, and in this case the electrons do not have to pass because we are going to send them from the negative to U, V, W. Now we have an open line. Well, with that we are controlling quite a bit of an IPM. Of course, this is the voltage-free test. We still have the voltage test, but to this point we are quite advanced. We are testing this component that is the IPM, a component that is damaged a lot because it handles a lot of power. We were testing it in this way, in function of diodes and without disassembling, which is key. The idea is that you learn to do those measurements without completely disassembling a board. Well, let's keep going. Here I have an IPM that I wanted to show you. What we tested was the IPM, which goes placed like this, but from the other side. In this case, we have an IKCM15F60GA. This is the model of the component. Don't worry, later we'll talk about how to acquire these components. We'll talk about the price, how to have them shipped to you. So don't worry, we'll talk about it a lot. Excellent, this was the voltage-free test. Please leave a comment if you have any questions.